All right, let's do one more example. This is a similar but different example. Let's watch a little clip first. So I have a little clip here. This is from Dennis the Menace. You're going to watch this from start at 20 seconds, and then you just watch it until about 41 seconds. You can go ahead and click on this right about here. Watch it. All right, so what we saw here was Dennis shooting this paint blob up into the air, and it goes up into the air, and then it stops, and then it comes back down. So it looks something like this. You have this blob that goes up in the air, comes back down, and it lands on top of, gosh, what's his name? That guy. I don't remember. Anyway, it lands on that guy's barbecue grill. Now, nice thing about this clip, like in the Baby Huey clip, is that it shows very clearly that at the top, that the velocity goes to 0. The velocity in the y direction goes to 0. What it doesn't do, kind of like with the Baby Huey clip, is that it doesn't show the two symmetrical. But we'll assume that it is symmetrical. We'll forget about sort of blowing into the tree, and also that this blob is deforming as it goes up. We're just going to take it as a very typical free fall problem. I have a total time from the clip equal to, just from watching the clip, about 13 seconds. And I want to know a couple of things. I want to know what is the initial speed, that is, I want to know what is v0, and I want to know how high does it go. All right, so I want to know the speed down here, and then I want to know this distance. So what I'm going to do first is look at the top of the motion. At the top of the motion, I have v equals 0. All right, so I have v equals 0. The time required to get to the top is going to be 13 divided by 2 seconds. That's 6.5 seconds. Because as we said, we're assuming that it's symmetrical, and so equal amount of time to go up and to come down. So we're just splitting that 13 seconds in two. And I know that my acceleration is minus 9.8. And so then I can say v is equal to v0 plus at. V is 0, v0, I want to know, minus 9.8 times 6.5. And then solving for v0, I find that v0 is equal to 9.8 times 6.5, which is 64 meters per second. That's pretty fast, 64 meters per second. That's over 100 miles an hour. But it goes up really high, so you know that it has to be going pretty fast. Obviously not physical, but for it to go up, for it to be in the air for that long, its initial velocity has to be pretty high. All right, so let's go ahead and find out what is the y displacement. We just say y, y is equal to v0 t plus 1/2 a t squared. That's going to be, now we know, 64 meters per second times the time, which we want to know that the maximum height, so we're going to use 6.5 seconds because that's the time that is elapsed when it's at the top. It's 1/2 of minus 9.8 times 6.5 squared. Try putting that into your calculator, I get 210 meters, which seems reasonable. It appears to be pretty high in the video clip. And as we said, for it to be that in the air for that long, for 13 seconds, that's a really long time to be in the air. It's going to have to go pretty high. All right, I think that's the end of chapter 2. Should go ahead and be working on the homework problem, and we'll move to chapter 3.